Okay, welcome dear students. We're going to do the November 2019 question paper now, and this one is actually our first question. So let's dive right into question 1 where we do algebra. So let's see what we have here. So for starters, you're always asked to solve for x, and solving for x has never been a problem. So for this one, you check which brackets you can use. You're thinking of two numbers that you multiply to get -6. When you add, you get +5. So definitely those numbers, the bigger number should be positive in this situation, because you can see that they should have different signs because of the -6. So the bigger number should be positive, and I'm already thinking you can see that it is +6 and -1 like that, and then you will realize that your x is just equal to either -6 or your x is equal to 1. That's how you handle an equation such as that. I doubt I have to explain anything on that one. And then when it comes to the quadratic equation where you have to solve correct to 2 decimal places, just make sure it is in this, if it is in standard form, such as ax squared plus bx plus c, as we are noticing, we just quickly put it into the quadratic formula. So the quadratic formula simply says minus b plus or minus square root of b squared minus 4ac all over 2a. So if you go and make your substitutions, you can see that your b this time is +3 plus or minus, you know, it has to be in the form ax squared plus bx plus c. You know, that's how you see your a, b, and your c. So you go and you say b squared, which in this situation is 3 squared minus 4, and your a is 4 and your c is -5. And then you handle your business like this. So apparently you have to put the step where you simplify the b squared minus 4ac, things that are under that root sign. So you have to give us that step as well. So if you do it, you get -3 plus or minus. When you simplify b squared minus 4ac this time, you get 89. So you know what your discriminant is at this situation. So after that, of course, you can give it to us now to 2 decimal places. And I believe you find it very simple to do. So your x here from your calculator should give you -1.55, or you can get your x value in the same manner as 0.8 like this. So right here you can write it as 0.80, especially if the question is asking you to do it to 2 decimal places. All right, so that's very simple, I should think. Let's go to 1.13. We also want to solve a quadratic. It's more like an inequality this time around. So when we do inequalities, most of the times, we first of all put things to one side, make sure the equation is in standard form, and if it is in standard form, you factorize, then you use your graphical method to handle it. So in this situation, it was not really a trinomial of a sort. It was actually a difference of 2 squares. So you ask yourself, what do you square to get 4x? Rather, what do you square to get 4? That's a 2. What do you square to get x squared? That would be x. And then what do you square to get 1? You will get 1 there as well. So once you get the first bracket, you just get the other bracket by changing the sign, and you say this is equal to smaller than 0. So after this, after you factorize like this, you're ready to get your roots. To get your roots, you just go and equate the brackets to 0 and solve. So it means your x is equal to +1/2, or your x is equal to -1/2. Now from here you go to your quadratic, the graph itself. So you're going to put it on a graph. Let's do it quickly like this. We have 2 roots which are equidistant from the y-axis, so we're going to put -1/2 here and +1/2 over there. And since our a, which is in this situation 4x squared, it means that our graph is smiling, if I may. It is concave up. So this is the graph that you will have if you were to sketch this one. So after you sketch it, then you ask yourself, you want the time when the function is smaller than 0. So it means you want the part of the graph that is below the x-axis. If it's smaller than 0, you want the part of the graph that's below the x-axis. So this is the part you want, the one that I am highlighting. As you are noticing, it is in between our roots. Okay, let me not shade those areas, otherwise you will think that they are included. So it is in between the roots that we have, and since we are not including them, we're just going to leave that as well. So our x here will be in between without including the negative half and the positive half. So right there is how you were supposed to solve that one. So I have a friend pressing all sorts of buttons on my board. Okay, so let's quickly figure out what we can do here before a friend presses the wrong buttons altogether. So what we have here on 1.14 is it's more like a third equation, but we have to think a little bit outside the box here. So I just want to see if you remember that if I have root 3 times root 2, what do you think I'll have as my solution? Well, I want you to know that it is the same as just saying root 3 times root 2, which is actually just root 6, isn't it? So you can put these things in under one root sign if they are multiplying. So it's the situation we find ourselves in. There are those root signs that we have over there, and they are multiplying as we are noticing. So I am asking us to put those under one big root sign and then put everything that is underneath. And whatever is underneath at this point is actually root of 32 plus x. It is under that first one. And then there is the second one, which is root of 32 minus x. Well, as we're doing all of this, we notice we're getting a difference of 2 squares under the root sign. So if you have a difference of 2 squares, you should be able to know exactly how to handle it. So I said before, you just go to the bracket that has got a negative sign, and then you square the first term, which is a root of 32. So let me write that step actually. So you put your big root sign, which is the blue one, and then I'm saying to simplify this, you square the first term, which in this situation, root 32 times root 32, you get just 32. And then you say minus, and then you square the second term, which you get it by saying x squared. So this is precisely what we have in this situation. And then I'll say it is equal to x. So you can FOIL, you'll get to the same place anyway. So at this point, if you're watching this video at this time of the year, it means you're ready to write. So I'm pretty sure that you will find this easy to see. So at this point, I believe you're saying, since we now have a third equation, we can now just square both sides and handle our business from there like that. So we will have only 32 minus x squared left this side, and on the other side there will be x squared. So I'm going to take the other x squared to this side. We'll have 2x squared, and it is 32. If I divide by 2 both sides, I'll get x squared as equal to 16, which if I square root both sides, I will get plus or minus 4. So those are my two solutions I'm seemingly getting at this point. But what we know is that we have to test or to check if the solutions are working perfectly. So I'll just go to this step, which is easier to check. So there is a step which we have here, which says that, okay, before we squared on this step here, on this step, before we put that squared, that is how it looked like. So please people, if I go and check my positive 4, it means I'll have 3 minus 4 squared. Let me see if it is equal to 4 on the other side. Is this correct? So I'm substituting 4 squared. I think that is 32. Okay, I am missing a 2. So let's put a 2 over there, and let's put that 2 over there. So it's going to be 32 and then minus 16, which will still be 16, and the square root of 16 will be equal to 16. So 4 is working. So 4 is a solution. What if I do the same with, actually, let's do it with negative 4. So I'm going to substitute 32 minus, and then I say negative 4 in place of x. Okay, am I doing it right? Okay, let's see if this is going to be equal to negative 4. Well, from what we are seeing here, it's still the same thing. It's 32 minus 16, which will be 16. So square root of 16, remember we only take the positive part, so this one won't work. So the only solution that will work here is x of positive 4 after checking. All right, so that's what we do with surd equations and with things like this. Just watch out for them. It's quite interesting to be able to do stuff like that. Well, then we have a simultaneous equation. That one is everyone's favorite, I think. So what you do if you have two equations such as these ones, you just make sure you make one of them subject to the formula. Like, for example, I can go and say, well, y in this situation is equal to 12 minus x. I can write it like that. So we already have our equation 1, and that one is equation 2. What I can do is now call this one equation 3, and I'll say substitute equation 3 right into equation 2. So what it means is that wherever I see y in that one, I'll go and put 12 minus x, and then I go and say 14 minus 3x like this. So that's all there is to it, and nothing serious. So I believe you are seeing that this is going to be that as I multiply and carry on this way. So if I take everything to one side, as we are carrying on with this one, I believe you'll see that it will be x squared here now, and then minus 3 minus 12, it will be negative 15x, and then the plus 14 was already this side. And if we try to factorize these ones, we are looking for factors of 14 that will add us to give us 15. I mean, it has to be 14 itself and 1. So let's quickly write x of negative 14 and x of negative 1. We will get our two solutions of 14 or x of 1 in this situation. So please people, those are the x values for this simultaneous equation. We need to now find the y value. So to get the y value, you have to just go and substitute the x values you got. So it's more like 12, rather 12 minus 14. So 12 minus 14, you get your negative 2 for the y value, and then we see what's what. Okay, so let's put y here of negative 2, right? And then we see if we substitute another one, what it is that we get. So we go and we substitute 12 minus 1, so we should get y of 11. So here this one will go with y of positive 11, so that should be easy to see. All right, that was the simultaneous equation. Let's quickly figure out if we have anything else in this question 1. It's a very simple task to do question 1. So, well, there was this one which was kind of a little out of the box a little. You were supposed to determine the largest value of k such that 3 to the power k is a factor of this product. Well, any number that we have here, 1, 2, 3, 4, 5, since it's multiplying, it means every digit that we have there all the way to 30 is actually a factor. But then we want the largest value of 3 to the power k, which is a factor. So it means we are interested in the factors of 3. So what we are going to do, multiples of 3, if I may, not factors. So at this point, you just see how many 3s you can get. Which numbers can 3 go into? Or 3 to the power something. I was going to start with 1 because 1 itself is already 3 to the power 0, but that 0 won't help us with anything eventually. So I'm just going to start at 3, and 3 itself is just 3 times 1. So let me just reduce, let's 3 to the power 1. So we would like to see as we go. So after that, I believe you get your 6 as well. So your 6 has got 3 inside. That one is 3 to the power 1 times 2. We don't really mind. And then what is the next one? 9. 9 is actually 3 squared. And the next number, which 3 can go into, would be 12. And that is 3 times 4. Really, we are interested in the 3 part and seeing 3 to the power what. Okay, so the next number that 3 can go into would be 15, and that would be 3 times 5. So it means it's 3 to the power 1 here that we get on this 15. And 18, it's 3 times 6. Or is there a better way of expressing, because it does look like 6 itself is also 3 times 2. So we can say 3 squared, isn't it? For 18, we can say 3 squared multiplied by 2. Okay, that's 18. And then the next thing we have is 21. 21 is 7 times 3. That should be 3 to the power 1, right? I hope you're following what I'm doing here. I'm making all powers of 3, and so that I can see is 3 to the power what that will work for me in this situation. Okay, I'm on 21, so let's keep moving. So if I go to 24, it is 3 goes there how many times? 8 times. So I'm going to write it as 3 to the power 1 again times 8. So and then after this, after 24, we have 27. 27 is actually 3 to the power of 3 altogether. And then lastly, it's 30 itself, which is 3 times 5 is 3 to the power 1. So what we are going to do is to take all the powers and add them together. That will be the maximum 3 to the power k that goes in there. So it will be 3 raised to the power. For this one, it's 1 plus this 1 plus that 2 plus that 1. And then I'm going to add that 1, then this 2, and then that 1 over there, and then this 1, let's put it, and then that's 3, and then that 1, right? That should be the last one. So if you can add here, I think we'll be done in no time at all. So 1 plus 1, that's 2, 2, that's 2 plus 2, that's 4, 5, 6. Okay, I'm saying 1, 2, 4, 5, 6, 7, 8, 9, 10, and then plus 3, 13. So it'll be 3 raised to the power of 14. So remember, we wanted the largest value of k. From what we are gathering, our k should be equal to 14 in this regard. So please, people, that is your algebra, and that was your November 2019. Let's quickly finish off this question, but for now, let's take a short break. Okay.